Welcome back. And you're thinking, looking cool, FJ, or probably, why are you trying to impersonate Casey Neistat? Well, I'm wearing sunglasses for neither of those reasons. Today, I want to talk to you about sunglasses, Polaroid filters, and particularly why wearing Polaroid sunglasses can be a real problem if you're a pilot. So, there's a whole range of different types of sunglasses you can wear, and they've all got slightly different filters in to block out the light. But what I'm going to work with today, just to make it easier, is I'm going to use the glasses that you get when you watch a 3D movie. And perhaps you didn't realise that this is what you look like when you sit there facing the screen. So if you buy an expensive pair of sunglasses, you might want to check out whether they're called Polaroid sunglasses. There are two different types, those that have Polaroid filters in them and sunglasses which just have a normal filter in them. So the bottom ones I'm wearing at the moment happen to be Polaroid, even though they're shiny on the outside of the lens. The middle ones are just normal darkened glass. And the ones up here, these are the ones you use when you're watching the 3D movie. And they do have Polaroid filters in. So let's see what we can do with them. So to do this experiment, I need the two lenses from a pair of Polaroid glasses. And instead of popping out the ones from these, which are a bit more expensive, I'm just going to use a pair from the cinema and actually just push. I call them lenses, but in fact they're filters. And if you push hard enough, they just pop out. You might notice that they actually have a little notch bit sticking out there, which enables them to put them into the glasses the right way around. But the strange thing is that if you lie two Polaroid sunglasses on top of each other and then rotate them, or in this case I take the two Polaroid lenses or Polaroid filters out of the cinema glasses and put them together and rotate them, you get a slightly darkened image. But then if I put it in front of this one and rotate it, it goes dark again. But if I flip it over, you might notice it goes completely black. So I'll just remind you what I did there. I took two semi-transparent, I mean they're pretty see-through bits of material. One or two of you might notice what's happening when I put this in front of my sunglasses. And then I just put those two transparent bits of material together and I get complete darkness. It's not just reducing the light intensity, it's blocking it completely. But when I rotate and rotate, not a great deal happens with these, but when I put them like that, it's totally see-through. Now this is really strange and is going to take some explaining. So for the sake of this video, let's quickly recap what I did. I took the two filters out of the Polaroid glasses that are used in the cinema and I put one on top of the other one. But then what I did was I just rotated one of them through 90 degrees. And when I do that, the light's completely blocked. And if I rotate again through another 90 degrees, you can see the light comes through. Another 90 degrees and it's blocked. And back 360 or back to where we started. Now, this is going to be a problem for pilots who wear sunglasses, and I'll explain why in a minute. But what I've also got to do is explain why does putting two transparent things on top of each other do something so strange when you turn it through 90 degrees. And before I explain that, this is the proof on whether you've got real Polaroid sunglasses. You need to put two pairs of sunglasses together and rotate one of them, and if it blocks the light, then you know you've got genuine Polaroid filters. And Polaroid filters are quite expensive. So I said I'd explain why this is a problem for pilots when they wear sunglasses. In old aircraft, like the one I fly, most of the instruments in it are of the old-fashioned analog type. So here's an altimeter, and it has a needle in it that goes around and tells me how high I'm flying. And with sunglasses on, it might look a little bit darker, but it's perfectly easy to read it. The problem arises when you have digital instruments, and we've just changed the radio in ours, and this may become a problem. Because with a digital instrument, you might have a liquid crystal display, and when you wear your sunglasses, at certain angles you'll notice I can see through to the display, that's fine. But if I tilt my head in the cockpit slightly wearing Polaroid sunglasses, the meters and instruments become almost impossible to read, and I have to tilt my head back again to be able to read them. And you notice there I only used one sheet of Polaroid filter. So where's the other one? Well, the other sheet of Polaroid's actually in the liquid crystal device. They use Polaroid filters. They use a single Polaroid filter in front of the liquid crystal. So if you've got the one in your sunglasses and you've got the one in the meter on top of each other, then slight angling of your sunglasses, if they're Polaroid, will completely black out the image. So I need to explain what's actually going on. So, time for an explanation. If you remember, we had two sheets of Polaroid, one on top of the other, and if we rotated through 90 degrees, it completely blocked out the light. Rotating back through another 90, and it was totally transparent again. What you need to know to explain this is the fact that light is a wave, and it wiggles up and down. It's a transverse wave. There are different types of Polaroid, and the ones we're going to talk about at the moment are linear Polaroids. The ones that are in the glasses you use in the cinema are slightly more complicated, so when you play with those, you'll see some even more interesting effects. So, light's a transverse wave, and as it wiggles through space going up and down, if we put a Polaroid in the way, the Polaroid behaves like these bars in this metal grill. And you can imagine that the wave comes along and slots through the bars and makes it out to the other side. But what happens if we take another Polaroid and put it in front and also make those bars vertical? Well, the wave will go through the first one and through the second one. But what if we turn either of them through 90 degrees? If we do that, we're actually in this case going to block the first wave that can't get through because the bars aren't vertical. And so it never makes it through to the second one. But if we go back to the vertical arrangement and rotate the one at the back, the same problem arises. It makes it through the first set and gets blocked by the second one. But of course, this is where the 90 degrees comes in. Because if they'll get through the first bars and the second bars are rotated back 90 degrees, we've now got back to two vertical bar sets, and the wave can wiggle through both. So these metal frames are modelling Polaroid filters. The Polaroid filters have molecules in them that are stretched out in this sort of way, and they interact with the light photons in that way. So, I hope you enjoyed that explanation of Polaroid filters and why pilots have to be a bit careful when wearing Polaroid glasses in the cockpit. I'll see you next time.